Started. Good afternoon. I hope all of you survived the snowstorms yesterday. Those of you in DC who enjoyed the snow hole. We got about 8 inches here in North Carolina, but I'm glad that we have our speaker here today and that all of you have been able to join us. I'm Leah Shanley, the co-executive director of the South Big Data Innovation Hub here at the University of North Carolina, Chapel Hill. For those of you who may not be familiar, the South Big Data Innovation Hub catalyzes and strengthens public-private partnerships that apply data science and analytics to regional and national challenges. The hub is co-managed both by UNC here at Chapel Hill and Georgia Tech. Before we get started, I'd like to mention a few things. First, for those of you who tweet, please use the hashtag SBDH17 for South Big Data Hub. We should change that to 18. I take that back. For those who tweet, hashtag South Big Data Hub 18, as well as hashtag BD Hubs, so it'll reach all the hubs in the country. For those of you who follow us on Twitter, it's at South Big Data Hub. And with that, I'd like to welcome you to our South Big Data Hub Roundtable series, a monthly series that provides an open forum for exploring emerging research challenges in data science and identifying potential solutions. Our discussion today will focus on the newly formed Energy Efficient Mobility Systems program in the Vehicle Technologies Office at the Department of Energy. We are pleased to have a distinguished speaker here with us today from that office. I'd like to introduce Dr. Rachael Nealer, who's program manager of the analytics team at the Vehicle Technologies Office at DOE. The team's work focuses on vehicle technology data, vehicle and systems modeling, and integrated applied analysis of transportation sector. Dr. Nealer is here today to connect with researchers in the big data hubs who may have an interest in collaborating with the DOE on research in this new sub-program that they're actively growing. So with that, I'll hand it over to Rachael.
Great, thanks so much, Leah. Can everyone hear me?
Yes.
Okay, great. All right, going to my PowerPoint. Can you all see the PowerPoint?
Yes, thank you.
Great. Well, thank you so much for the introduction. I'm excited to talk to you guys today about our new sub-program in the Vehicle Technologies Office called Energy Efficient Mobility Systems. So this is a pretty new program. It was first formed about a year ago. We're still staffing it up and really getting our feet under us as far as research and development, and wanted to share with you some of the opportunities for funding and just give you a little bit of background of the program so that you can keep an eye out for future funding. All right. Sorry, I'm having a little bit of technical difficulty. Let's try this one more time. Okay. So mobility is a large part of our energy economy today. It's the second largest expense for U.S. households. It consumes a large portion of energy across the nation. Most of our transportation uses petroleum, and actually 70% of the total U.S. petroleum usage is for transportation, and of that petroleum usage, 85% of it goes to on-road vehicles. So the Department of Energy obviously has a dog in the fight here to improve energy efficiency and reduce our energy use in transportation through a couple different means, both through kind of technology, innovations, as well as what we will talk about a little bit more, part of the energy efficient mobility systems is looking at the full system and how we can improve energy efficiencies, not only through those technical components or technical specific research and development opportunities, but also across the full system, which incorporates some behavior and other aspects of the transportation sector, like fuel switching as well. So right now we see a lot of different trends really shaping mobility. So we have a growing population. We have people that are being more concentrated in these mega regions, in urban areas. We have people that are living longer. We have people that are really dealing with transportation in a different way than we have ever done before, with things like iPhones and technology really enabling some of this. And so we also have these kind of technology trends that are happening in mobility today, like the integration of connected and automated vehicles, or technologies within vehicles. Those are, starting to be on the road even today. We have introduction of shared service platforms. So those are things like Uber and Lyft, and other, not only shared mobility in terms of sharing rides, but also sharing vehicles. So we've got Car2Go, Zipcar. Those are many different sharing platforms that affect transportation. We've got advancements in energy storage technology. So Department of Energy has spent a lot of resources in trying to reduce the cost of batteries in order to make electric vehicles a more prevalent alternative fuel compared to petroleum or gasoline vehicles. So with those battery costs going down, that potentially makes electric vehicles more available to larger populations. We've got deeper application of big data. So how can we, utilize a lot of the data that is collected and really kind of figure out where we can build out efficiencies within transportation using that big data. Then we also have faster processing speeds at decreasing costs. So that's really the computational strong arm behind the deeper application of big data, and that's getting bigger. It's getting faster and faster, and we're able to do it at these decreasing costs, especially at the national lab level, where we have some supercomputers that we could potentially use in order to solve some of these kind of larger transportation system issues, as opposed to some of the computing capabilities or computing limitations that we may have today in turning this big data into energy efficient solutions. So these trends are all really causing this fundamental disruption in transportation. Like I said before, people are really interacting with transportation in a very different way than we have before. And even Mary Barra, the CEO of GM, has said that she believes that transportation is going to change more in the next 5 years than it has in decades. So we're really changing very fast, and we want to make sure that we're doing this in the most energy efficient way possible. So what we must understand as DOE is how these things like connectivity, ride hailing, new powertrains like electric vehicles, new modes like automated shuttles, car sharing, and automation, how that disruption will lead to new energy efficient opportunities, what we can do, how we can manage the risks to energy use and how we may be able to overcome them, and what are the most promising levers in terms of technology for sustainable energy future. So this is just a quick visual of kind of how we're organized. So in yellow here is our new subprogram under the Vehicle Technologies Office called Energy Efficient Mobility Systems. This is in the Department of Energy's Energy Efficiency and Renewable Energy Office, EERE. We also have still a lot of research and development happening in electrification and batteries, materials technologies like lightweighting, and investigating different materials to improve the efficiency of vehicles, largely by reducing their weight. Advanced combustion systems and fuels, so looking at how, even if we were to use gasoline today and into the future, because it is the most dominant fuel today, that how can we make that as efficient as possible? And then we have technology integration, which is looking at how we kind of interact with cities, and we have these two major initiatives, Clean Cities, which some of you may be familiar with, and a new one called Living Labs, where there's a couple pilot projects that we have ongoing or have just started that will look at kind of these applications of technologies. And then off to the side is actually where I sit, which is analysis, communications, and operations. And so what the analysis team does is kind of supports all of these sub-programs and really takes some of the targets within, so the office sets targets for each of these sub-programs. Our electrification target around batteries is something like a cost target per kilowatt hour. Material technologies is increasing the lightweighting materials within vehicles. So those type of technical targets, the analysis team then takes and tries to understand how that impacts the entire transportation sector. And although I'm not officially part of the Energy Efficient Mobility Systems sub-program, that's our program manager, David Anderson, I do support it quite significantly because we're continuing to staff up, and EEMS is what we call it in short, has kind of come out of some ideas that we've had in the analysis program about looking at transportation systems more broadly. And so each one of our sub-programs really focuses on improving energy efficiency, increasing domestic energy security, reducing the operating costs for consumers and businesses, and improving global competitiveness of the U.S. economy. So diving a little bit deeper into the EEMS program, we have a couple different initiatives within the program. So we have the first thing that kind of came out of a collaboration between the analysis program and the EEMS program was the Smart Mobility Lab Consortium. We have two new initiatives in high performance computing and big data analytics. We have additional advanced research and development projects that we're just kicking off. Like I said, the EEMS Living Labs, we have a couple pilot projects there as well. And then some core VTO evaluation and simulation tools are needed in order to do the analysis under EEMS that we need to in order to understand the energy impacts of these transportation systems and changes in them. So starting with Smart Mobility Lab Consortium, so this is a 5-lab consortium looking at connected and automated vehicles, mobility decision science, urban science, advanced fueling infrastructure, and multimodal transportation. So this is very analysis heavy. Each one of the labs kind of spearheads one of these activities, but it truly is multi-lab in its efforts. So many researchers are working on different parts of these across the different labs. So the labs are Argonne National Lab, Idaho National Lab, Lawrence Berkeley National Lab, Oak Ridge National Lab, and the National Renewable Energy Lab. And you can see on the right some of the things that we are targeting. So quantifying some of these energy savings potential of vehicle connectivity and automation in merging roadway scenario. So that's being done at Oak Ridge under the multimodal pillar is what we call them. Quantifying some of the energy benefits of connected and automated vehicle enabled drive smoothing for multiple powertrains. That's being done at Argonne National Lab under the TABS pillar. Modeling charging requirements for electrified shared mobility service fleets. That's being done at Idaho National Lab and the National Renewable Energy Lab under advanced fueling infrastructure. And that's a way to basically look at how we can optimize infrastructure in order to make sure that it's very accessible to not only electrified but shared mobility services. And then analyzing energy impacts of autonomous driving in Chicago metropolitan area using agent-based transportation simulation. That's another thing under Argonne in the connected and automated vehicles pillar. And this is just to give you a little bit of the flavor of the projects that are happening. They're very technical. They're kind of at a smaller scale. As you can see, one of them is a Chicago metropolitan area. and the merging roadway scenarios, so a little bit smaller scale that we're really hoping that we can roll up into some larger national impacts of how these different components of smart mobility affect energy and the transportation system. So HPC and big data analytics, we have two different initiatives kind of under that umbrella. And this is, again, at the national labs. So HPC for Mobility is a small seedling project to partner with national labs so that they can have the computing expertise and resources to solve some of these transportation problems or kind of find some energy efficient solutions. Big transportation data analytics is also national lab based and looks at how to apply these big data techniques. So that's being run by Lawrence Berkeley National Lab, and the HPC for Mobility is being run by Oak Ridge National Lab. And both of these are to help us develop and apply the expertise that we have at the labs through things like high performance computing. Like I said before, the supercomputers are a big component of that, the machine learning capabilities, and the big data science to find the solutions to some of the transportation issues that are happening today in our cities and regions. So some of the advanced research and development projects is a funding opportunity announcement that went out a little while ago that just kicked off. There are 3 different winners. 2 of them are here. But the whole point of that was to partner with industry and academia to research and develop mobility technology solutions for energy savings. So one of the projects is the University of Michigan that is developing a spatio-temporal intersection control system that reduces fuel use by 15% while improving travel time. So here you can see a couple of these different metrics kind of creeping in. We're not only looking at energy, but we have to incorporate travel time because that is of importance to the consumer and how the technologies may be adopted. And then the Clemson University, they kicked off a collaborative traffic and vehicle control algorithms to achieve 10% energy savings through, and that will be validated through on-track vehicle in the loop test beds. So our living labs are really bringing this a little bit more to the cities. And so this is working with cities and stakeholders for field evaluation. So we have our technology integration sub-program, which is kind of its own sub-program, but we recognize that especially with some of these new technologies, we need some sort of feedback loop from not only what the cities are dealing with, what problems they're trying to solve, whether it's energy, whether it's congestion, whether it's emissions. We need some of that to help motivate some of our research and development solutions. But we also want the feedback loop in terms of the technology. So some of the technologies are already available today, things like different levels of automated driving, lane assist, that type of thing is available today. And so if we can get some real world energy implications of those technologies, that can help feed our research and development portfolio as well. And so we have 2 projects here. I think there is a third one that is not on here. So this is RPI looking at energy efficient logistics using freight demand management to manage freight patterns to reduce energy use and support energy efficient goods movement. We haven't talked too much about the freight side of things yet, but with the increase of things like Amazon and just-in-time manufacturing and delivery to your door of your groceries, we can see a lot of potential in expanding the freight sector, but we want to do so again in an energy efficient way. The second one here is the City of Seattle. who is evaluating the technical applicability of electrification in shared mobility applications in 4 major US markets. So again, shared seems to be something that is going to really unlock some of the potential of energy savings. As you can imagine, driving a car by yourself, you can allocate all of that energy to a single person, but if you add even one person, that halves the energy use of the vehicle per person, basically. So we really see there's a lot of value in trying to enable some of these shared situations. And not only enable those, but we see through some of the early research of Ubers and Lyfts that people are very responsive to shared mobility because it comes at a cheaper cost as well to consumers. So some of the core evaluation and simulation tools are here on the right. I won't go through all of them, but you can kind of see that we need a lot of capabilities in order to do the modeling and simulation that is going to give us the insights that we need in order to really unlock these energy efficient futures in transportation. So we've got test procedure development, highly instrumented hardware evaluation, so things like dynamometers, looking at the vehicles and how they could be operated differently, control algorithm validation, high fidelity physical simulations, and transportation data management and analysis. And so if you have any questions about the models on the right, they are from mostly, I believe, our national lab system, which is where we do a lot of our core work for this program and kind of the Vehicle Technologies Office. But the EEMS program has definitely reached out to some more stakeholders in order to collaborate on many activities. Just a note here on a memo of understanding that we had between DOT and DOE. So as you can imagine, our missions overlap quite a bit. DOE is kind of coming from the position of trying to make technologies available in order for a more energy efficient transportation system, where DOT actually has a little bit more of a regulatory arm in this, but they are also interested in the safety, which is not something that we focus specifically on. It is, of course, of interest to us, and we would never want to undercut safety because of these technologies, but it is not technically part of our mission. And so we are really working hard to collaborate with the Department of Transportation in order to try to understand these technologies a little bit more holistically. And one way that we have done that is to partner in the DOT Smart City Challenge with the Vehicle Technologies Office Smart Mobility Lab Consortium, so that we can really try to address some of that feedback loop of what is going on in the cities. And so the Smart City Challenge winner was Columbus, and so they've got a lot of goals in order to make their transportation system more efficient over time. They have a lot of data coming in that could be very useful to provide some insights for DOE to feed some of our larger research and development, as well as giving some of Columbus the accessibility to some of our capabilities at the lab. So we've had a couple things come out of this collaboration, which included support of a technologist in cities, where one of our National Renewable Energy Lab employees actually went to Columbus on a frequent basis in order to really try to understand their needs, and if there were any research opportunities that we would be able to step in and help with. So we also provided Columbus with an infrastructure assessment for alternative fuel vehicles in the Columbus region. You know, they have goals about how many electric vehicles they want on the road. And so we provided some support to tell them how many vehicle charging stations they may need to invest in order to support those electric vehicles. And we're actually going even a step further to make kind of a simplified version of that tool available to all cities, so that you can really kind of understand some of the relationships that we find in our research, but can really be deployed at the city level. So, you know, major disruptions are already occurring in transportation, and we want to make sure that we're doing this in the most efficient way possible. Connecting to automated vehicles is obviously a part of that, but we also see shared mobility as a way to potentially reduce emissions. And right now we're building up the EEMS program and trying to, so we've had a year of research so far, and we're really trying to, as well as kick off many of these programs, but we're really trying to build a base of what transportation looks like, not only at the component level, but the full transportation system, so that we can really make the greatest reductions in energy as possible into the future. So thank you so much.
Wonderful. Thank you, Rachel. With that, we'd like to open it up for questions for those who are participating. Or Rachel, you mentioned, maybe to get started, you mentioned that the DOE is very interested in reaching out to researchers for collaborations on this. Where do you see specifically that there are opportunities for folks in our hub, academic researchers, private sector researchers, to plug in?
Sure. So I would keep an eye out for our funding opportunities announcements. So that's basically how DOE funds things. You know, we put a FOA, is what we call them, out, and you have kind of a concept paper level where you submit a concept paper to us. We review it, and then we'll either encourage or discourage a full proposal. So I would just keep an eye out. I can make sure that you, there's actually what's called EERE Exchange, where we have all of our FOAs listed. So that's FOAs for Fuel Cell Technologies Office, Bioenergy Technologies Office, as well as Vehicle Technologies Office. So there might be a lot there. It actually goes across even some of our other EERE offices, not just transportation. So you might have to dig a little bit. Government is not really known for its pretty websites. So apologies for that, but we can try to keep you posted potentially through, if it's, you know, Carl and Leah are available to help us, you know, get the word out. If there are any funding announcements, we can send you guys emails. We also have a EEMS database of stakeholders. So if you're really interested in this and you see it aligns well with your research, please do reach out to me, and I can get you on that database, that basically the large distribution list. So when there are any big updates, the FOAs, those funding announcements will definitely be things that we blast out email in order to get the most robust projects.
Okay, so people can see that on this Rachel's slide here, she has her contact information so that you can get on that list. Also, Rachel, we would be delighted if you send us those announcements that we could broadcast through all the four hubs, through our monthly newsletters and our own membership listservs. Folks on the line, anyone have questions? Carl, I'll leave you that to help us manage. It looks like there's three questions.
Yes, there are 3 questions in. The first is, how can cities get the tool you mentioned, Rachel?
Yeah, so that is probably something that will come out in a blast, either on the distribution list. I can also send it around to Leah and Carl. when that is available. We're working on trying to get that done in the next couple months. So hopefully we can send that soon, but it's not quite ready for public distribution yet. But it's getting close, and we're excited to debut it soon. It's just as an FYI, it is an extension of what is called the EVI Pro model from the National Renewable Energy Lab.
Great. Carl, can you remind people with Zoom, may not be familiar with Zoom, how they can post a question to the group?
Sure. At the bottom of the screen, there's a ribbon. Q&A is one of the options. And you can type in your question there.
Great. Okay. So one of the other questions that have been posted, so the South Big Data Hub led an effort in collaboration with the other hubs to build a partnership with the European Union's Big Data Value Association, which is a mix of private sector corporations that are working in the big data R&D space, as well as academic and government partners. So a delegation of about 25 US researchers from across all 4 hubs went to Europe to begin to meet some of their Horizon 2020 and Big Data Value Association Lighthouse projects. Transportation was one of those areas of interest. So the researcher here on the line has asked, how does your effort here in the US compare to that of other countries? And what are some of the most impressive efforts in other countries?
Thanks. So Department of Energy is, I might sidestep your question a little bit. Department of Energy is really focused on domestic energy. So although we are, there are other parts of department, actually I should say, there are other parts of the Department of Energy that focus on the international aspects. The Vehicle Technologies Office is really domestically focused. I think we try to stay abreast of the different technologies that are really taking off in different countries. China has really made impressive efforts in electric vehicle market penetration, largely due to their incentives from the government. So I think that's pretty interesting. But I think generally we're really focused on domestic energy use and how we can improve that. But if you're interested in some more international aspects of it, we could probably put you in connection with some of the international office staff here at DOE. And I think we also have most of our collaboration internationally has been on things like the batteries and electrification, because you can imagine that's a pretty global industry right now, and different countries are kind of taking different approaches. So that's most of our international engagement.
Okay. Tyler Folsom asks, why are you thinking inside the box? He's working to automate a production vehicle that gets 1,800 miles per gallon. The vehicle weighs 160 pounds and is legally a bicycle. Are you looking at the space between cars and bicycles?
So with a majority of people transporting themselves in the light duty sector by cars, I would say that it is not a big focus. However, the urban science portion of the Smart Mobility Consortium is looking more at kind of how the city interacts with transportation. So, and we also have a multimodal pillar within the Smart Mobility Consortium. I wouldn't say the multimodal is really as focused on bicycles or smaller vehicles, but really does look at kind of how people are using different modes to get around, whether that's transit, by bus, or by light rail. So I wouldn't say a large portion of our research is in the small vehicles, but we're definitely aware of it and know that it could have some potential energy big energy impacts.
Okay, great. Are there any other questions from those online participating? Again, you can enter your questions at the bottom under Q&A in the bottom navigation bar. We've also just posted in chat Rachel's email address, which is Rachel.Nealer@ee.doe.gov. So that's in the chat box. Rachel, your web address, vehicles.energy.gov, is that all it is? HTTPS at vehicles.
Yes, that's our Vehicle Technologies Office homepage.
All right. Somebody typed they had trouble getting to it. Great. Well, I don't see any other questions at this time. People are probably still recovering from digging out their cars today after the snowstorms. Rachel, do you have any additional last thoughts that you want to, let's see, am I missing any other questions? Looks like somebody's raising their hands. Carl, am I missing someone? I don't know, it looks like Tyler has asked a question. Okay. Any last questions before we wrap things up? I see one executive director from the Midwest Hub on the line, Melissa Cragen. Do you want to mention some of the activities going on in the West Hub in this area? No? Maybe not. Okay, well, Rachel, would you like to offer some closing thoughts?
Thanks. No, I really appreciate the opportunity to present to you guys today. Like I said, you know, this is a new program. We're really trying to build it up, and we're really trying to engage with lots of stakeholders. As you can imagine, the umbrella of EEMS activities is quite large. And so we really want to try to be as impactful as possible. And so understanding what other researchers are working on, as well as what cities and regions are dealing with and what problems they need to solve, and also incorporating some of these energy impacts is really important to us. So we look forward to hearing from you, and please let me know if you want to be added to the stakeholder list, and we will be in touch.
Wonderful. Thank you, Rachel. And I see a note from Melissa that she apologizes, but she doesn't have audio access. I encourage those of you who are on the line to reach out to your executive directors in the various hubs. If you are doing transportation research, and particularly if you're doing research in this area and would like to build connections, and reach out to Dr. Nealer directly. I'd like to extend a warm thank you to our speaker, Dr. Nealer, and to our audience for their time for today's engaging discussion. Thank you, everyone. And I'd like to offer a few reminders before we close about upcoming South Hub events that may be of interest. The Microsoft Cloud AI Research Challenge, and that's actually an all-hub activity with Microsoft, offers a chance to see what you can do with Microsoft.com/AI services like Azure Machine Learning, Cognitive Services, Data Science VM, Batch AI, and Bot Framework. A grand prize of $25,000 is available. The deadline to apply for Cloud AI resources is February 15th of this year, so that's coming up pretty fast. And the deadline for submissions is April 15th. Visit their website for more information, and also look to our newsletter for that information. The Data Up program will allow you to bring data science to your campus. Hands-on training is available for instructor teams at minority-serving institutions, community colleges, or four-year liberal arts colleges. Priority will be given to hosts who can demonstrate the participation of faculty from diverse departments or multiple institutions of the types listed above. The deadline to apply is February 23rd, and more information can be found on the South Hub website and newsletters. The final reports and webinars for Keeping Data Science Broad are available. Thank you to the many authors and contributors from the South Hub and outside our hub. You can find these materials on the South Hub website. The next Security Networks and Social Computing Working Group for the South Hub will be held on Thursday, February 1st at 11 a.m. Eastern. Emails will go out through our newsletter reminders. While it's a South Hub run working group, we welcome researchers from all over the country to participate in that. And the next All Hub Data Sharing and Cyber Infrastructure Working Group will be held on Friday, February 2nd at 3 p.m. Eastern. Please email me, Leah Shanley, and I'll put my email in here if you have any questions about what was talked about today or want to get in touch with folks. Thank you very much, all, and have a great day, great weekend.